Experiment number 3. Dry preparation of disturbed soil samples. The activity aims to impart the standard preparation of disturbed soil samples. Throughout the experiment, the students shall be able to prepare disturbed soil samples for future laboratory experiments and distinguish unacceptable practices in preparation of soil samples. Prior to that, let's discuss first. The dry preparation method is essential for preparing soil samples for laboratory tests such as moisture content determination, particle size analysis, and Atterberg limits assessment. Inaccurate soil sample preparation, such as incomplete drying or insufficient breakdown of aggregates, can significantly reduce the reliability of test results. Thus, it compromises engineering designs. With that, proper techniques like sample splitting are important to ensure accurate results. Being cautious with preparation also guarantees that enough material of the correct particle size is available for all required laboratory tests, avoiding repeating the process. This process typically involves careful drying, standard sieving, and regular sample splitting techniques like coning and quartering or riffle splitting to maintain sample integrity and sufficient quantity for each test. Additionally, preventing contamination through clean equipment and proper storage and documentation of every step is a must. Following these best practices in dry soil sample preparation will improve the validity and reproducibility of laboratory experiments. Here are the equipment that you will be needing for this experiment. Triple beam balance, oven with temperature control, pans, standard sieves number 4 and number 10, rubber mallet or rubber-covered pestle, mortar and rubber pestle trowel, and sample splitter. Here are the steps that you will follow. First, allow the soil sample collected from the field to air dry thoroughly at room temperature until it reaches a constant dry condition. Once fully dried, gently break down any soil aggregates using a mortar and pestle, ensuring that the particles are carefully disintegrated without crushing the individual grains. From this prepared sample, obtain approximately 75 grams for the determination of moisture content. Next, pass the soil sample through sieve No. 10 to separate the coarser and finer fractions. The material retained on sieve No. 10 should be carefully collected and then crushed again using a mortar and pestle to further break down any remaining lumps or clods. After crushing, re-sieve the material using sieve No. 10 to ensure proper separation and a more uniform distribution of particle sizes. After sieving, determine the mass of the material retained on sieve No. 10. The retained fraction should then be thoroughly washed to remove any adhering fine particles that may still be attached to the coarser grains. Following washing, dry the material completely in preparation for accurate weighing. Then record the final mass as the coarse material fraction. Subsequently, the dried coarse fraction is further sieved using sieve No. 4. And the mass of the material retained on this sieve is carefully measured and recorded for analysis. Finally, the soil fraction that passes through sieve No. 10 from the earlier sieving processes should be thoroughly mixed to ensure uniformity. Using a sample splitter, obtain a representative subsample of approximately 120 grams for particle size distribution analysis. In addition, collect about 200 grams of the material passing sieve No. 40 for use in determining soil index properties and other soil constants, ensuring that all subsamples are properly labeled and stored for subsequent testing. The dry preparation of disturbed soil samples is an essential process in geotechnical laboratory testing that ensures soil is properly conditioned for accurate analysis. Through air drying, breaking of aggregates, sieving, and proper sample splitting, a representative and uniform soil sample is obtained for various tests. The experiment emphasized the importance of correct preparation techniques to avoid errors that may affect results, such as improper drying or inconsistent sample handling. Proper execution of each step ensures reliable data for moisture content, particle size distribution, and soil index properties. Overall, following standard dry preparation procedures improves the accuracy and reliability of laboratory soil testing results, which is critical in engineering applications. Thank you so much for watching. I hope you learned something today.